Thank you for joining us today for the JPS Weekly Product Briefing Webcast. I am Carroll Hollingsworth. I'm the JPS Vice President of Sales. Iggy Bragado, the JPS Senior Sales Engineer, will provide you with today's program on the Z2 controller. We really appreciate your being with us today. We know that your time is valuable. We know that we're all working differently under different conditions, and it's really appreciated, and we thank you for being with us today. At this time, let's get to the real reason we're all here today. Let me introduce Iggy Bragado. Iggy?
Okay, Carroll, appreciate it. Thank you. Thank everybody for attending, and I'd like to welcome you to the JPS Interoperability Solutions Weekly Product Briefing Webcast. And I'm Iggy Bragado, Senior Sales Engineer, and Carroll Hollingsworth, our Vice President of Sales. And in this week's webinar, we're going to discuss another addition to the Z product line, and that would be the Z2 controller, which is will truly complement the RSP Z2 dual channel gateway that we discussed in our last product briefing webinar. But before we begin, I'd like to review a few things that we discussed during our last webcast, and that's the methods JPS uses to transport radio as well as telephony communications between remote devices over the network. And as you may recall, we offer two JPS proprietary protocols, and it would be JPS RoIP and JPS Bridge channels, and two standards-based protocols, SIP and RTP. And obviously, each of these protocols has their own advantages and disadvantages, but we do provide those options. And many of our gateways have all these protocols combined into a single device, like the RSP Z2 dual channel gateway, which we discussed on our last webcast. So depending on your requirements and the capabilities of your network, you have all those choices. And in some cases, you might need to consider a hybrid approach and combine different protocols to solve your communication issues. So Carroll mentioned in the future, we might talk about applications, and we might look at some of the applications that would require a hybrid approach in terms of the delivery of radio and telephony communications over the network. And I also added the typical network bandwidth requirements for each of these protocols, and you'll notice that the JPS RoIP protocol can utilize up to 5 user selectable vocoders, and one of those vocoders is GSM, which only requires 13 kilobits of network bandwidth. And really, this is one of the benefits of JPS RoIP. So let's also review the RSP Z2 dual channel gateway, as it's really one of the fundamental pieces of a distributed Z architecture when in the presence of the Z controller, which is the subject of this week's webcast. And as you may recall, the RSP Z2 dual channel gateway has 3 user selectable configurations, or sometimes called patterns, that are selectable from the module's integral web services. And remember, this architecture does not rely on external servers. Users must use web browsers to securely log into the RSP Z2 to manage and configure the unit. And so the most basic configuration is a single cross connection, very simple single cross connection. As you can see, the two interfaces can either support radio talk groups, JPS RoIP links, or even standards-based protocols such as RTP and SIP. The interfaces can even support many push-to-talk over cellular applications such as ES-Chat or JPS VIA. And you can also even plug in a wireless headset transceiver into the front of the unit's USB port to serve as another resource. Another pattern is a cross connection with a network backhaul. And in this single backhaul solution, you can utilize JPS RoIP and the standards-based protocols, SIP and RTP, as well as a push-to-talk application if you like. We'll talk about bridging channels here in a moment. So the bridging channels are really important in terms of the Z2 controller. And lastly, there is the independent pass-through pattern where two interfaces are completely segregated and then separately backhauled using network protocols that we just described. So when we use different transport protocols to route radio and telephony voice communications from one gateway to other remote gateways, we could use those protocols. So last webcast, we mainly discussed the single gateway solutions. And now that we know a little bit about digital transport protocols that we offer, we can now construct larger, more complex systems with multiple gateways. And so in this example, we have 3 RSPZ dual channel gateways, all sharing voice communications. And in this situation, we're using JPS RoIP protocols. It can also be SIP or RTP for that matter. Again, you have those choices. But in this example, I chose to use JPS RoIP because I may want to use the GSM vocoder that utilizes only 13 kilobits of network bandwidth, and JPS RoIP link is also inherently self-healing. And so there's a lot of advantages of using JPS RoIP as your transport protocol. If I need one gateway to talk to a completely remote gateway, I'll need to log into the gateways to re-provision the network backhaul interfaces. It's not difficult, but requires some expertise to re-provision those interfaces. And again, it's not difficult, but maybe inappropriate sometimes, especially in a mission-critical moment. So that's where JPS Bridge channels can be employed in conjunction with the controller to provide instantaneous and very dynamic sharing of voice communications over the network. The Z2 controller was introduced last year, and it's actually finding its way into other gateway products, such as the anticipated ACU Z1 modular gateway, which should be introduced this summer. We'll certainly have a products briefing webcast on the ACU Z1 as soon as the product is introduced. The Z2 controller looks very similar to the RSP-Z2 dual channel gateway. And just like the RSP-Z2, the controller contains a 1 gigahertz quad core processor. It's also powered by 12 volts DC, as well as 120 and 230 volts AC. All those are standard. And the unit draws less than 500 milliamps of current, just like the RSP-Z2. But one of the differences is that the Z2 controller is interfaceless. So meaning there are no provisions to connect a JPS radio interface cable to the unit. And so one of the main purposes of the Z2 controller is its ability to manage large systems of gateways, primarily the newer gateways within the Z family of products. But also other JPS gateways in our catalog, such as the ACU 2000, ACUMs, ACU 5000, and even NXUs. The Z2 controller does have the ability to manage up to 80 communication resources. So for example, I might have a system that consists of 40 separate RSP Z2 dual channel gateways. And it also provides a nice user interface that allows the management of the network voice links utilizing JPS Bridge channels and JPS RoIP. Let's take a look at our previous example where we linked 3 RSP Z2 dual channel gateways into a larger single system. And instead of using point-to-point RoIP or RTP network links, the presence of the Z2 controller can now help manage bridge channel network interfaces of the RSP Z2 gateways. And up until now, we haven't really talked about bridge channels. But what a bridge channel is that it acts as a mediator or a middleman between the network and the actual communication interface. And again, that interface can be a radio talk group. It can be RoIP, SIP, or RTP. And you can see that at the top of the RSP-Z2 module image. And so in this example, the bridge channels are associated to radio interfaces of the RSP-Z2, which is highlighted in the red text. And so in this example, the radio talk group is associated or bonded strongly to a bridge channel interface. And so just like a switchboard, one bridge channel can be virtually associated to another bridge channel over the network using the integral controller management browser, which we'll see here in a moment. Bridge channels have lots of user control and flexibility and dynamics without the need to be burdened with the provisioning of the network protocol interface. It's literally done automatically. And users can even consolidate any combination of interoperability by linking multiple bridge channels together using the controller user interface. So here's the example of the Z2 controller browser user interface. We'll look at a live one here shortly. And just like the Z2 controller, users will use their username and password credentials to log into the controller. And remember, this architecture does not rely on external servers, but instead the web services are embedded within the hardware themselves. And by using browsers, users can utilize PCs, Macs, iOS, or even Android platforms. So I'm going to switch to my live controller screen. So give me a moment here. Incidentally, I'm located in San Jose, and I've got my RSB Z2s here in San Jose with my radio assets. But the controller, the Z2 controller that I'm using, is located in our engineering lab at JPS in Raleigh, North Carolina. So this is really a good example of distributed communications. On the left of the user interface are the available free resources that can consist of bridge channels, RoIP channel interfaces. And remember, the actual communication environment, for instance, a radio, is sort of disguised as a bridge channel. But as an operator, I really don't need to know that. And so as long as the bridge channel is properly labeled, for instance, with the agency's radio channel name, I, as an operator, should have full confidence that I'm actually managing that specific radio channel. In the panel here on the left, the free resources panel, we have RSP Z2 and ACU Z1 resources, push to talk over cellular assets, for instance, ES-Chat or JPS Via, and those are all free resources. And we even have standards JPS RoIP resources that are also found on our other products, such as the ACU 2000s, the ACU Ms, NXUs, which I'll explain in greater detail in a moment. So a free resource can be dragged into any existing interoperability net. So I can grab a resource and simply just drag it into a separate interoperable domain. And since these interfaces are full duplex, all parties within that net will be able to conduct two-way communications. So in essence, when once one resource receives, all other resources will transmit. You can even create a completely new net by right-clicking on the free resource icon. And remember, these are bridge channels or RoIP channels. All right, so I can move a free resource into the new net, or I can even move resources that are already in an existing net and move them to the free net in this example. And remember, all I'm doing is moving around bridge channels just like a switchboard operator. So by creating separate nets, I'm essentially segregating communications because some communications might not be relevant to others. This will also help reduce the saturation of radio systems by separating non-relevant radio traffic. And even from the Z2 controller, we can even access the settings page of a remote asset. In this case, let's say I need to check the settings of a remote RSP Z2 channel. I can right-click on that asset, and I can go ahead and click settings. You may notice that I'm still within the controller. And this is a very good opportunity to show you some of the inner workings of the controller. And as you can see, the resource that I moved into the net is viewed as a radio asset by the operator. But in the administrative channel pages, the asset is actually bound to a bridging channel. The bridge channel and the actual asset the operator sees are really one and the same. And again, they're very tightly bound by the bridge channel. The operator sees a resource that is identified as a radio resource, but actually behind the curtain, the resource is again bound by the bridge channel. So depending on your administrative roles given to you, you might not even have access to this page. Remember, we talked about setting up permissions and roles. In this case, if I look at this screen, there are no radio-centric settings that I can use to adjust the bridge channel. So however, I can go to the actual remote asset by clicking on Go to Settings. Let me go ahead and select that. And I'm going to be directed to the remote asset. And this is the remote asset, which is the RSP Z2. All right, so now in this example, now that I'm in the remote gateway, I can make adjustments to the digital signal processor. But let me go to the home page of the RSP Z2, and I want you to see the independent pass-through configuration that I have set up for this gateway that's here in San Jose. And you'll notice that the interface, which I have selected as a radio interface, is selected for channel 1, and the backhaul through the independent pass-through is set up as a bridge channel. And this is the bridge channel that is being controlled by the controller. So let's go back to the settings panel. And again, my permissions and roles allow me to do this. And we can see all the interfaces in the dual channel RSPZ2 gateway. Again, this is my radio interface. This is my bridging channel. And by selecting the radio interface, I now have full access to the digital signal processor. I might want to, for instance, adjust the 38 dB of transmit or receive audio level dynamic range, or even adjust the transmit or receive audio delay settings. And incidentally, we can buffer up to 5 seconds of transmit audio within the RSPZ2 dual channel gateway. And this is particularly useful when dealing with radio systems that exhibit some kind of process delay, such as trunk radio systems or even latent SATCOM radio connections. Right. So let me return to the Z2 controller. And so again, this allowed me from the Z2 controller to access that remote asset. All right, so we're back in the Z2 controller, and from the bridge setup page, we can manage the bridge and RoIP channel interfaces of the remote gateway. So just like an invite list, resources must be indicated as either bridge channels or RoIP interfaces within the bridge channel listing. Otherwise, those remote assets cannot be managed, or their radio or telephony voice communications cannot be shared amongst other resources within the system. And remember, we can support as many as 80 communication resources from a single Z2 controller. One last thing I want to look at is the bridge settings panel of the controller, and that would be the link type selections. And you'll notice that you can define the network link from the remote gateway as either a bridge channel or an RoIP channel. And we'll talk more about the differences between the bridge and the RoIP channel in a moment. And so that's very important in terms of working with some of our legacy devices or even existing gateways that a customer or an end user might have. All right, so as you remember, bridge channels interact with the actual communication interface, be it a radio, RTP, SIP, or RoIP, but bridge channels also act as an agent or a middleman that the controller uses to dynamically create the network links to access remote assets. But by implementing bridge channels, the controller also has lots of influence on the operation of the actual communication interface, as you can see on the right. As you saw when I engaged the settings of the remote RSPZ2 in the live demo. So the bridge channel has lots of those enhanced capabilities that other transport protocols really can't provide. And in fact, we may see bridge channels completely disappear in the future and be virtualized directly into the communication interface of the gateway, making it completely transparent. Bridge channels are already perceived as transparent to the operator of the Z2 controller user interface. So the controller treats RoIP channels differently than bridge channels. From the Z2 controller's bridge settings page, as you remember, we had the opportunity to define whether the remote gateway network interface is either a bridge channel or an RoIP channel, as we saw earlier. And the biggest advantage of defining the remote asset as a RoIP channel is that it allows other JPS products such as NXUs, ACU 2000s, ACUMs, and ACU 5000 that do not have the Z-class bridging channel protocols embedded. They can now be partially managed by the Z2 controller and operate in concert with newer transport protocols and management protocols that we have in the other Z products. However, there is a caveat, and the Z controller itself cannot directly manage the interoperability or cross connections of those legacy gateways. But there are some technical provisioning tricks that can be applied to NXUs, and particularly the ACU 2000, to make them fully manageable by the Z2 controller. And in this example, the remote ACU 2000 is part of a larger Z architecture, but by virtue of the RoIP channel assignments, the gateway must, however, be controlled by an ACU controller. So there's lots of technical ways around this, but the nice thing about the use of a RoIP channel is it now allows us to include our other legacy devices into the Z architecture. This provides us a really nice, versatile, and a hybrid architecture. And to conclude, there are two versions of the Z2 controller with respect to the quantity of resources that it can manage, and that would be the number of supported communication resources, and that would be either 24 or 80 resources. So we have two tiers of support in terms of communication resources out at the edge, and this would be per Z2 controller. We're also looking into a cloud-based controller that would be able to manage well over 80 resources for very large systems. And by the way, all the standard features discussed in this webcast are free from reoccurring or licensing fees. At the left, you can see the current Z-Class product line, which primarily utilize bridging channels. And at the right are our current and legacy products, all of which can be included into the Z architecture using RoIP channels managed by the Z controller. And at the center are our JPS applications that are fully compatible with the Z architecture. And there was one Z2 controller feature that I purposely did not mention, and I'd like to reserve that for our next product briefing webcast scheduled for next week. And that would be the dispatch function within the controller, which incidentally is also a standard feature of the controller. And in that webcast, we'll also introduce the MCC4 multi-channel desktop console product, which you can see at the right. So hopefully you will be able to join us for that webcast. So I'd like to thank everybody for joining us on today's webcast. And if you need further information regarding the Z2 controller or any of the Z-Class products, you can always contact us directly, contact Carroll or I, or visit the website at jpsinterop.com. And Carroll, do you have something you want to close with?
I just want to thank everyone for joining us today. And again, I hope that you'll be able to join us again next Wednesday. If you have any questions, if there's anything that we can do for you, our phones are always on, whether it's customer service or sales. So any way we can support you, please stay safe, and we hope to see you next Wednesday. Thank you.
All right. Thank you, everybody. Appreciate it.